Assalamu alaikum. In this video we will continue what we started in chapter 3, functions and introduction to recursion. To start with, I would like everybody to select his group by first clicking on the select a group, because activity 3.7 has to be a group work, so you have to work in a group to solve this homework, only for this homework. Now selecting a group is kind of simple. You just see whatever group is available. You just click, for example, if I want to be the first to have group 1, just select group 1 and then save my changes, my choices. If I know this person here, I would like to join him, I just click on G2 and then save changes. My name will be added to this name here, so it will be as if I'm joining that group. Fine. You can see the limit is 3, so here 1 is taken. I have 3 limits. The limit is 3. All groups has a limit size of 3, so make sure you select a group that has a space to be entered. Now saying that, we can start now with our Rand program. Now this is an empty program as usual. If you execute, you get nothing. I'll just call it Rand. We can find it very useful and helpful to have a random number generator to help us simulate a case that we would like to study. Say if, for example, instead of having to enter like 10 student numbers, taking a quiz, we can simulate 10 students that took the quiz and just generate their grade numbers. After that, we can have an average, minimum and maximum of that simulation. So this is our topic to do now. Before that, let us understand how Rand is being used. So cout, it's simple as just Rand. This is a function. If I execute, it will give me a random number. So as we have here, 41 is my random number. As I told you at the beginning, it gives numbers between 0 and 32,000 something. So to give even chances for all numbers, if I call it again, it will give me another number. If I call it again, let me every time have a new line, just to make things clear. Now if I call it again, now I'll get 2 random numbers here. Every time I call this function, it gives me a new random number generated from the computer itself. It's based on some mathematical equation that is already built in the system. See, now we have 41, then 18,467. Say instead of just keep printing cout, I can just put it in a for loop. As we all know, int I equals 1, I is less than or equals to 10, then I plus plus if we have like 10 students. Then I just remove this one just to have it print 10 times a random number. This will save me time instead of just keep printing cout Rand every time. Now see here, we have, these are 10 numbers. They look random since there is no way to predict what's the number it's gonna generate after this 24,000. Actually it's kind of repeating itself. If you can remember that every time we're printing, it gives me 41 in my case here, then 18,460. It's repeating the same numbers. This we will fix later, but for now let's concentrate on having a quiz. We never grade to like 25,500, something like this. It's my quiz is out of 10 marks, so I would like to have these numbers just shrink down to either 0 to 10. To do this, there's a simple technique, is having it modulus by 10. This will give me 0 to 9. So if I put it modulus 11, it will give me from 0 to 10. So this will fix my problem. If I execute this code here, I'll get all grades in the range that I'm looking for, as we have here. So it's 8, the first number, since this is modulus 11. 41 modulus 11 is 8. Then we have 9, 9, 1, 7, 5, 5, 10, 1 and 0. So these just imagine this is a simulation of students that took a quiz with me, and I would like to have an average and min max to these grades. If I execute again, see, these are the same numbers. We will fix this later and see how we can every time get different numbers, so it will be more too realistic. And having different random numbers every time will make, if we're gonna like write a game, it will make it more interested, since the player cannot predict every time he plays the same game. He cannot predict the behavior at every time he repeats playing the game. Now let's go back here and finish up this average thing, and then we'll discuss how to make it real random numbers every time. Now having generated 10 numbers, every time we are printing it to the screen, and there is no trace to calculate all these numbers or whatever. So we need to keep track of these numbers. So instead of printing them directly, I would like, say, to have it in a variable. So just call it x equals, and I no longer need this NL since I'm not printing now. X needs to be defined, so it's an integer. Now, so x will calculate, x will hold the random number that is generated. Then first thing to do is just print it out. Now next I'm gonna add them all together. So I'll call a sum a variable. I just call it sum, so I need to define it and initialize it by 0. Otherwise I'll just first time I will keep adding the random number to some garbage value, because if you don't initialize it here, you'll be in a problem of adding a number to something that is unknown. So sum equals sum plus x that has just been generated here. Now then let's finish this, and then we'll deal with the min max thing. Now once we've done, I just want to print out the sum, so I'll say sorry, the average grade is, it's nothing but sum divided by 10. So let me print this here. So it's sum divided by 10.0, just to make it a floating point result. Now I put this thing here. We have an error. It says here endl declared. Yeah, this is end. I just, this is a typo. I just forgot the L. And then I think I missed something here. There is an extra bracket. This one here is for this guy, and then this one is for, no, this is an extra. I don't need this one. This is for the for loop. Okay, and this is the begin of the main, and here we have the end of the main. So I'm done. We see these are the numbers 8, 9, 9, 1 all the way to 0. The average is 5.5. So the average was 5.5 for these numbers. It looks like a normal distribution so far. Now I would like to have the minimum and the maximum value. To do this, usually we have like min, and we'll put min, and then we have max. Fine. Usually I do this by assuming min and max equals the first value. So I'll just copy this one here, copy the first iteration. So I'll pick up one of these and just put it here, Control V. Since I took one of them out, I took one iteration out, so it should go to 9, not to 10, because this is one of them, and I need 9 more. I need 9 more because there are all total of 10 students. The reason that I took one iteration outside the loop is that I would like to have further processing on it. Further processing means I need to assume this first x, this x that has been generated by the system, I would like to assume this first x as the min and the max. So min equals x and max equals x. So I'm assuming the first element to be a min and a max. If it is different from this min and max, it will be dealt with inside the loop. So inside the loop, of course I have to add this x because it's one of the iteration, so everything remains the same. Now here, every time I'm gonna check if the min that I assumed is greater than the new x that has been generated, because once I entered here, there is an x generated, newly generated x that has been printed. This is from the second and third all the way to 9th time. I'm checking if this new x is less than the min that I assumed of being the first number. Then this x should be my new min. This means that min now equals to x. And if my max is less than this x that has been generated, then the max, my new max now, should be this x. This will guarantee that every time it loops, if it finds an x that is less than the min, it will reassign the min to be equal to that x. and if the new generated x is greater than my max, then it will reassign it, and it will keep checking every time it generates a new x whether it's less than the min and adjust that one, or if it's greater than the max, then adjust that one. At the end of the loop, it will guarantee that I have a min max that will service my purpose here. And now the max grade is max, and the min grade is, just print min. Fine. I think I made a typo here, yeah. Now we have here 899. We still have the same numbers, but now the average is 5.5, the maximum grade is 10, minimum grade is 0. We are done with this thing here. Now if I would like to have different numbers, I should seed the random number generator. Normally it is seeded at 1. So if I seed, so let's have this here before I do anything. After the declaration of the variables, if I say like srand, I just do it once. I just seed it to, actually it's normally seeded to 1, just to check things here. See, it's giving me the same numbers, 899. So this proves that it is seeded at 1. If I seed it at 2, then it gives me different numbers. See, now I have a lower average class. I have 10984449. So it gave me different numbers because I seed it at a different number. If I seed it, so you can't just seed it at any number here, like you can have 1000, seed it at 1000. Just execute. I have 4.4, but these are different numbers, but the average is 4.4. Now we are still looping on, yani we are related on having a different seed every time. So I don't want the user to change the seed manually. I just want it to be random. The best thing to do is just have this as time 0, since at time you can never have the same time running the program at the same time, the same split second every time you execute it on an everyday. It's really hard to match that thing. So time 0 means, let me first show what time 0 will print before I use it here. So I will comment everything here. Let me comment and come back to this code after I explain what's, yeah, now this is how to comment a bulk of code. Just put star / at the end and / at the beginning, so it will comment everything. So if I execute, there's nothing to be executed, as we have here. Now saying so, I just would like to print cout time 0 and see what happens. Time 0, actually it goes with an include. I have to include, otherwise it will give me an error, because this function is included in the ctime library. Now and I'll execute. It will give me an unsigned long number, long integer like this. Let me execute again. We'll see it looks similar but not exactly. Let me show you what happens if I just keep printing these things in a loop. So for loop int I equals 1, I less than or equals to like 10,000, I plus plus. Every time I'm gonna print this thing here and tell me what you see. Can you see what? Now it's printing. It just printed a thousand integer, and you can see if I go up all the way, it's changing every second. It's changing the last number here. Every second it's changing the last number. So this is think of it as a timer of seconds. First time booting the computer or something really back in time. Now, so time zero is a big integer that it's really hard to get it back again, unless you execute the same code at the same second. So if you execute it again, so you run it and then keep running it again at the same second, then you'll get the same seed. Now having this said, we can just remove this thing here and just take this out. Now time zero will give me the time in seconds that will be generated from the computer. I'll use this as my srand, as a seed, hence I'll get a random output every time I execute this code. Now see, this is a 2.1 average class, so I have 300901, so it's really a bad class here. Let me execute again. Now this one here is 4.6. It's a bit better class. Then let's execute again. Now I have here it's 4.7. Execute again. 4.9. See, every time I'm executing, I'm getting different numbers. Totally different number. This is 5.1 now. A better average. Execute. See, so this is an average 5, minimum 0, maximum 10. So this will conclude using the rand, the srand. This is the srand, and time zero as a function to generate a time every time we would like to have a different execution. So having this implemented, we can simulate almost everything we would like to have a random number generated, say for example into a game, into a scenario situation, whatever you would like to have to simulate. You can always use a random with srand and time to have your simulation calculated. Now let's go on to the second part. Now you can further see more details about rand and random and srand in your book. This is at page 158. This is chapter 3 section 8. Okay, so you can see the example that is given there in the book, And now we will see another topic here, the structure topic. So let me clean up everything. Okay, now we will start a new program here, a concept of passing by value and passing by reference. Before that, we would like to explain the concept of a local and a global variable. Now, variables can be defined within a function. Now, this is a function. We've seen how we can have a function outside the main, as we had before. Say, call it twice. We've seen this before. So twice will return an integer that's double the value of the argument that have been passed. So this is directly will return, or before that, let's say x equals x times 2, then return x. So I just multiplied x by 2 and then I'm returning x. This is a function that will return a value. So if I have a and then cn a, before that cout, please give me a value, then cout double your value is, or twice your value is, twice your value is L twice of a. Now then, and L, let me explain what I have here. Now I ask the user to enter a value, cna, so a is a value. Then I call the function that I just defined it as twice. The twice will multiply whatever argument, which is x. So a that I've entered to the computer here, a will be passed to twice. So a will replace the value of x here, and x will be multiplied by 2, and then I'm gonna return x as a return value for twice. So the whole function name will be replaced by the value of x after the modification here. So if I say what should I call it here, twice, if I call it with a value of 2, it will give me 4. If I call it with 8, it will give me 16, and so on. Now let me put like 5. So twice your value is 10. Now here we have a simple function that will return the twice of the value after multiplying it by 2. Now if I will have this code, cut it and just embed it here, so I don't need the return. So I don't need the return because it will print it inside. So I just remove this thing here, and that here I don't need to call the function, I'm just directly printing x, and hence guess what, this is no longer an int return value. It's a void because there is no return. It's doing all the job inside. So to finish things up, all I need to do now is just call twice and send it a, and that's it. I don't need to grab the return value because there is no return value. twice will do everything. So it will take care of everything here. It will multiply x by 2, and then it will print the value on the screen, and then it will print x, which has been multiplied by 2 already. Now if I execute this thing and print the same thing, 5, I get 10. Now what if I call a here, just I'm printing a instead of x? What happens? Guess what? Any suggestions? What happens if I print a? A is here. So will it print 5 instead of 10, or will it complain of? Yeah, so it complained. It's saying here that a is undeclared, so a is undefined in this function here, so it does not know a, all it knows is x. So this is what we call that a here is only defined in the main function. X here is only defined in the twice function. So these are local variables. So if I put this x again and say, if I would like to print the value of x, cout x is x. Now if I execute, it will complain here that x is undeclared. Even if it's here as an argument, but it is undeclared because x is a local variable only defined inside the function twice. A is a local variable just defined here. Now say if I have a value, I just define it outside any function. So here if I define it here, this doesn't belong to any function. Say int b equals 15. Now this is defined, this is as a global variable. Global variables can be printed and used in any function. Now if I execute, it will not complain. It will print it as we have here. If I say, for example, 2, it will not print 4, it will print b, which is 15. So it's printed b, which is 15 inside the twice function, and b is 15 inside the main function. See? Now to fix things, let's put it back x, and okay, I'll keep this as an indication of a global variable. Now say for example, if I'm cout a, do you think a has been changed after the function is? Do you think if I print a, will it still keep its original value, or will it be changed after I call it with the twice, because a has been substituted by x and x has been multiplied by 2, and then I printed x, it was changed. Now once I go back to the main function here, will a be changed to, say for example, if a was originally 2, will it be 4, or will it keep its original value? So this is a question that I would like you to test it on your computer and give me the result. So try it on your computer and see what happens and tell me the results. Okay, I hope you tried it. Now let me show you my results here. We said we will have 2. Now Will it be 4 or 2? I have after b is 15, a after the function is 2. So it has not been changed. It has not been changed. This is what we call I passed a by value. By only its value. Passing a by value will not change the original value because I only passed the value. I only passed the value to the function. But if I pass it by reference, it will change the original thing. If I pass it by reference, how can I pass a variable by reference? Only by adding this symbol here, like this. So if I add the ampersand, this symbol, it will pass x by reference. By reference means if I change x here inside this function, and x was passed as an argument that reflects a variable that is defined somewhere else, that variable will be changed accordingly. Now let's see the effect of having this ampersand. I'll put 2 again, see what happened. Now b is 15, this is a global variable. Then after the function, now a is 4. A is 4. This means that it has been changed. Now a that I have passed, when I print it now, it is 4. This means that this symbol here had affected the a that has been passed by any changes that has been done here. So this is what we call passing by reference. Passing by reference. So passing by value will not affect the original variable that has been passed as an argument to the function, but passing by reference will change it accordingly. Okay, so I hope this will clear out the difference between passing by value and passing by reference. There is a static variables that I will show you now, and hopefully we will stop at this point after we show the static. Let me close up here. So close and start a new static. Fine. Now if I have a function, say I call it it's void, then I call it count, and I pass int, or it's just counting. Inside this function I have int, then I have c as a counter, and I start c with 0. Then every time I'm adding 1 to c, so c++. In the main, I will for int I equals 1, this is I less than or equals to 10, I plus plus. Now every time I'm checking if I would like to check how many numbers are greater than 5 and how many numbers are less than 5. So I will check the rand mod 11. If this number is greater than 5, okay, I'll just count. So I'll call count, and count will add 1 to c, and then at the end I just see out, or that's that's it. Maybe I should cout here since it is void. So cout C and L. Now every time it's calling the function, every time it's calling the function count, this is count, it will increment C and print the C. When it will call the count only if my random number that has been generated is greater than or equals to 5. Okay, I just want to feel how many students got less greater than the letter the mark 5 for the 10 students. Now there is a problem here. I'll not show it now, but once I run, this is count. Now every time, now we have 1 2 3 4 5 6 7, so I have 7 students got a grade greater than 5, but every time C is 1 1 1 1 1. Now going here and printing 1 means count has been called, means I entered into this function, but C is still 1 because every time it is initialized, C is initialized by 0 and I just add 1 to it, and then once I exit, C is deleted from the memory. If you don't want to delete C from the memory and just keep it as the last value it got, just put static, so C will remain getting the last value it had. If I execute this one now C is incremented 1 2 3 4 5 6 7. So these are number of students that got a mark greater than 5 or equal. Now to repeat this, static is allowing me to keep the value of C after I exit from the function, so it will keep its last value. Once I enter again, it will not initialize it to 0 anymore. Only the first time it will initialize it. Later on, every time I execute this function, it will bring back the last value it had from the last execution. So this is the difference between the static and the normal integer. Again, static will keep the value, will keep its last value that I've got from the last execution. Now, having said that, we reach up the end of our class, and next class we will see more practice in using functions, and we will implement recursion, and we'll see what recursion means in the next lecture. I hope this video was useful, and please practice everything we've said in this video. Go back and implement them with your hand,